Hey, Vlad here, DevInsider.com. Welcome to my 100th video. I can't believe that it's been almost 2 years since I started this crusade. In the previous video, we have implemented the pretty typical methods on maps, and today we're going to continue with that, learn how maps interact with sets, and even have a tiny crash course about writing internal domain-specific languages. Let's get right to it. As always, we're in the Ubuntu virtual machine and we have Sublime, this time maximized because I'm on a smaller laptop, and we're using Terminus, an awesome plugin for Sublime Text, which emulates the entire terminal for us, which runs SBT, which reruns the tests every time we save the file. So this is exactly where we left off, and I made a few typos, so I'm just going to go and remove them real quick. So we have the line 687 with without over here, right? And in the sat suite in line 682 over here, forgot a parenthesis. There we go. So I'm just gonna open real quick another terminal, and I'm just gonna commit everything so that everything remains clean. We got refactoring this video 23. There we go. I'm gonna push it by the end of the video. The first thing that we're going to do today is we're going to remember what maps really are. They are a set of keys with a function on top of it. So today we're going to implement a different factory for maps, a different way to create maps, where we're going to take an existing set and basically just bolt on a function to it with some values. Right? So basically bolting on some values onto a set. So we're going to start, we're going to go to the, I'm going to have the set suite on the left and the set open over here. And go to the very bottom as we usually do, and we're going to add a new test. So this test is going to be called with some value. So the function that is going to be called with some value. So we're going to have a set dot with some values, and on an empty set, it should yield an empty map. As always, we're starting with a bad case scenario, with a sad path or whatever it's called. So we're going to go to set, and we're going to create an empty set with an integer like this, and we're going to go with some values, and unfortunately, at least in the beginning, we'll have to specify the parameters of the map, right? So the key is going to be an int, and the values are going to be strings. Okay, so what we'll do is we're going to pass in a partial function, right? We're going to say if it's a 1, then do a 1, and if it's a 2, then do a 2, and if it's a 3, then do a 3, and all of that should be map.empty int and string. There we go. And with some values, obviously it doesn't exist, so it's not going to compile. All right, so we're going to go to the set to the very bottom where we have the companion object. Right above the companion object, the class ends. So we're going to add the final def, and I'm just going to copy that with some values. There we go. And we're going to have to do this covariant dance that we have been doing for quite some time. And in fact, in this case, this covariance is actually the cause of us being forced to specify these parameters over here. And we're going to get rid of that a bit later. So the value of is going to be a partial function, right? Super value. And it's going to produce a map, right? So it's basically a factory for maps. All right. Equals, let me scroll down a little bit. All right, so what it will do is it will call another function that will be called with values, and the parameter is going to be a total function, right? So over here we have a partial function, and over there we're going to have a total function. In fact, let me write it out first. So we're going to have with values, and we're going to have the same covariance thing, right? Super element, and it gets the value, right? And now the difference. So the value of is going to be a function that maybe we should have some more space. Okay, even more space maybe, like that. All right, so the value of is going to be a total function that will take a super and produce an option of value. And there's a handy method defined on partial functions to convert a partial function of this type, super value, to a total function of super to option of value. And it's called lift. So all we need to do here is to say lift, right? And it will convert this type into, this type into that type, right? That's all we need, and it will produce the same thing. Map super value equals, and as always, we're going to fold, right? We're gonna fold over the set, and the parameters of the fold are going to be this map of super. Map of super and value. How did I end up with having multiple p's? Super and value over here. Right, so we're going to start with an empty map, and this is all that we have our test for. So we have ACC and current as always. Let me put the parentheses over here, right? And over here, for now, we're just going to throw an exception because our test is only testing the default case, this one. All right, so now we're going to go back to the tests, which should be green by now. Yep, they're green, and we're just going to add the next test. And the next test is going to be this. So we're going to have test, and let me scroll down a little bit. Test with some values should yield a map with this set as keys. All right, so this is the one that is basically the happy path, and it will be clear what it's actually doing. Okay, what's the with some values function actually doing? So we're gonna have to start with what we expect. So we expect this function, this map. Okay, and this is going to be our act. Our act is going to be, so we're gonna have a set with 1 and 3. All right, so the 2 is missing. Okay, that's very important. We're gonna call it with some values, was int and string. Okay, we're gonna pass in the same partial function as before, this one. All right, like this. All right, go here, paste it. All right, so notice that the 2 is now here, but over here it was missing, and this should be what we expected, right? And we're gonna have the same thing again, like this, but this time the 2 is going to be here, but it's not going to be here, right? So basically this new factory is an intersection of this set and of this partial function, right? So now we're going to go back and actually implement the with values function, right? So it's going to look like this. So the first thing that we're going to do is we're going to retrieve the value of the current key. And I forgot to call this one current key. I call it current, all right? So we're going to get the value of the current key. And if it exists, right, then we're going to be in this map over here, right? And if it doesn't exist, we're just going to leave the accumulation alone, right? So we're accumulating this entire map. So if it doesn't exist, we're just going to throw it out, right? So this one's basically the filter over here, right? Okay, so we have the value, and if it actually exists, then we're just going to add it to the map, right? So we're going to add the current key with the value. All right, so what are we going to do about this type inference issue? And the answer is DSLs. We're going to have to learn about DSLs. And the DSL, you might be asking, really? And the answer is yes, really. Okay, so what are DSLs? Well, Scala, as most programming languages, is what is known as a general purpose language, or GPL. Or in other words, you can program anything you want with it, from your computer to a space shuttle. And I understand that this definition is a bit hand-wavy and a bit vague, but I believe it actually gets the point across. There is another breed of programming languages called DSLs. They're designed for some specific purpose, for some specific niche, for some specific domain. For instance, HTML is a DSL to describe content. It is an external DSL. It is a language in its own right, so to say. There are also other DSLs out there, namely the internal DSLs. These are libraries inside of some host language, namely Scala in our case, which are handcrafted to visually suit some specific domain, and also they're used to enforce some specific domain constraints. For instance, Scala test, the library that we have been using all this time, is an internal DSL for the domain of testing. What we will create now is a tiny DSL for constructing maps, and the expressive power of our DSL depends solely on our imagination and the expressive power of the host language. And boy oh boy, Scala well suited for writing internal DSLs. This sounds way fancier than it actually is. In fact, there are only 2 techniques. Well, actually there are more, but these are the 2 primary techniques for writing internal DSLs. The first one is method chaining, also known as fluent interfaces, and the second one is called object scoping. Now, method chaining is what we have been doing all this time. Look, it looks like a chain. Set and then dot and then another dot, right? So the way you create it is basically to make sure that whatever you're calling on the set, right, for example, set empty int, is returning a set again, right? And then this object has another method that returns a set again, and this one has another method that returns a set again, right? So this is called fluent interface, where we basically just chain these methods. Object scoping is what we will learn about next. We're going to write a tiny DSL which will create flights for us. So we're going to go over here, we're going to create a new file, and we're going to save it right away as flights.scala, or maybe let's save it as dsl.scala. Right over here, we're going to create a case class called flight, and it's going to have a source and a destination string. Okay, we're also going to override toString, final override def toString, return the string, right? We're going to use string interpolation. We're going to say flight from source to destination. All right, so what we're going to do is we're going to have an object flight over here, which is going to be our DSL. We're not going to put anything in there for now. I'm just going to go and create a tiny main to show you what it's going to look like. So we're going to have an airport, which extends an app, right? With print line, my favorite hyphens. I don't remember them right now, but I remember the code. And we want to have 50 of them. 50 of them. All right. Do this twice. All right. So we already have a way to create a regular flight, right? So this is just a case class, right? So it's flight, let's say from Stuttgart, city in Germany, and Berlin, another city in Germany, right? And we can print out regular flight, and let's save that, and let me switch to running a main method. All right, so you're gonna say run main airport. There we go. Okay, so we see a flight from Stuttgart to Berlin, and now I can actually copy paste one of these hyphens and just put them over here like that. And there we go. All right, so what we want to have now is a fancy way to create flights. So we're going to have a fancy flight, and we want to go to this companion object, right, to this flight object, right, and we're going to add a method called from to it, and we're going to use the infix notation, and we want to be able to do something like this, Stuttgart, and then whatever object is being returned by the call to the method from, it will have another method called to, and we will be able to do that. Berlin, okay? So we're going to print out the fancy flight, and at the bottom, we're also going to make sure that they're exactly the same object, right? So the regular flight is exactly the same thing as the fancy flight. Now, obviously, right now, if I try to compile it, this method from doesn't exist. So we're going to go and edit. So adding it is going to look like this: from source string, and this creates a source. Now a source is going to be a class that is going to be inside of flight, and this is what is called object scoping, right? So it will create another source of source, which is this source is a string. Okay, so this is the object scoping, right? So this class is inside of this object, right? It's in the scope of this object, right? So it's going to be a class source, and is going to have a constructor which is only which is private to this flight. Okay, so we want to constrain some things, right? So it's going to create it's going to get a source of string. Okay, and this one is going to have the method called to, this one. Okay, so we're going to have a to gets a destination of string, and now it has everything it needs to actually produce a flight. So it's going to create a new flight, source, and destination, and actually flight is a case class, so I don't need the new here, right? There we go. All right. So now it should be fine, produce exactly the same thing, and returns true because literally it's exactly the same thing. So the next thing that we're going to do is we're going to do a similar thing for maps. So right now we have defined the methods on the set, right? So we have the set, and you can say dot with some values, and then we can say dot with values, right? So one of these. So what we're going to do now is we're going to go to the map, and we're going to go to the very bottom where we have the companion object of maps, and we're going to start adding a new thing over here. Right over here. So we're actually going to put our DSL on the left over here because we're going to start copy pasting stuff. All right, let's go back to map. So the DSL started with a method called from. So let's just copy that, paste it over here, because this is this is really like a general recipe. So what we want to have is to have something like this. If we have a map already, the companion object of map, we want to be able to say dot with keys, right? So this is going to be with keys, and this is going to be keys. Okay. Keys, and the keys is going to be the set of element, the element that is defined over here, element. Okay, and what it will produce is a source. I'm just going to keep calling it source so that you see the symmetry, but it's actually, we can call it DSL or something. It's going to produce a source of element, same way as before. We actually don't need that. All right, keys, right? And the same way as this one has a class source, we're also going to have, actually, let's make it final, just all right, so we're going to go here, and we're going to have a class source. It's going to have an element, and it's going to have a private constructor with a val called keys with a set of element. And we're actually going to try to have any val here. I'm actually not going to sure if it's going to work with the private constructor. Let's actually see. Let's actually see if it compiles. Does it compile? No. So it probably needs to be constructor source. What? It's in the same thing. All right, let's do this. All right, there we go. It worked. So now we're going to have the body of that class, and what we're going to insert into the body is whatever we had in the set, right? So we had with some values and with values. So we're just going to copy them. We're going to bring them over here, and we're going to rename them because we're constructing a new DSL. So what we're going to be able to do is to say map.with keys and some values, right? So this is going to be and some values. This is going to be and with values, or just and values, right? Like this, right? So it's either a map with keys and values or a map with keys and some values, all right? And the only thing that we need to do here is we're calling this fault on this, so we should now call it on keys. And I believe that is actually all we need to do. So now we can go to our test in the set suite over here. I'm losing my voice again. I'm still a bit sick. So we can go over here, and instead of saying set with some values, we can say, I'm going to start typing it somewhere over here, like this, okay? So I can say map with some keys, with keys, right? And then pass this set as a parameter, 1 and 3, all right? And now I can say and some values in string, and there we go. And as a parameter, we're going to have this partial function like that, right? And it should be the same thing. Should be expected. There we go. Should be expected. And maybe we should actually switch back to running the test instead of the main method over there. All right, so now everything is reformatted. All right, so this is a different DSL. So we can do set 1, 3 with some values, or map with keys and some values. Okay, in fact, we'll actually remove this one because I'm going to leave it for now. Okay, the cool thing that we sort of accidentally gained by this DSL is that the parameter element is not covariant anymore over here. See, the element over here, it is not covariant, whereas in the set, the element was covariant. It wasn't the covariant position, which means that now we can go to and some values and n values and remove this nastiness, right? So we don't need this super element over there, like this. And now everywhere where we say super, we're just going to use element, like this. And now it's obviously going to compile and the test is going to run. But now what we can do is we can go into and some values. It doesn't compile now because now and some values wants only one parameter, the string, this one, right? So now it's going to compile, but in fact now because covariance is not there anymore, there's, it's much easier for the type inference to infer the type, to reconstruct the type. So now we can remove it, and now our DSL is actually even more powerful than the methods on the set. Now, by the end of the video, this is going to be the solution that we will stick with, but at least for now, I want to show you an alternative that requires implicits. Now, remember in the video about variance, we stumbled upon implicits, and I promised you an entire video dedicated to implicits, which is coming soon, so please be patient. So now we're just going to repeat real quick. So we learned about implicit implicits, and today we're also going to learn about explicit implicits. All right, so we're going to create a new file over here, and I'm going to call it implicits. Implicits.scala, and we got some rendering issues over here, and there we go, implicits.scala. All right, so we're going to create the same thing as we created back then. So it's going to be object implicits. I'm going to type it out real quick, extends app, and it has a case class apple with weight in grams, which is an integer, grams, which is an integer, and it has a color, which is a string. Okay, and it also has a case class called orange, and orange only has the weight in grams, weight in grams, which is an integer. Okay, so we're going to have a function which takes an orange, right, produces a unit, and all it will do is it will print out print line orange, and also, as you already know, I like my hyphens. So where are my hyphens? DSL hyphens, there we go. These ones paste over here and paste it over here. Okay, so we have this function. All right, and what does it want? Illegal start. What? Oh, we need an equal sign over here. How did that happen? All right, so maybe actually let's switch to running this one. So we're gonna do run main implicits. And there we go, and we should see our orange if we actually call this function. So what we're going to have over here is we're going to call this function, right? And we're going to call it with an apple, right? We're going to say weight in grams is 300 and the color is red, which is not going to compile, right? Because this function wants an orange, right? So, and as we discovered in that video, so we have a function called, it doesn't actually matter how we call it, but I'm going to call it apple can be used as orange. Takes an apple, produce an orange, right? Takes an apple, produce an orange by just going to the orange factory and do apple weight in grams. It just basically throws out the color, okay? So now we can call this method over here like that. I'm going to let the scalar form inline everything. But then if we mark it implicit, then we actually don't need to do that. The compiler will do it for us based on the types. And as I promised, I'm going to have an explicit video for implicits. Anyway, so these are called implicits because you don't see how an apple is being converted to an orange, right? So this thing could live somewhere else and be brought in by an import. So you don't see this. So implicits are being a bit frowned upon. Be very, very careful with them. And I'm going to mention this 10,000 more times, especially in the video about implicits. So what we're going to learn about now is explicit implicits. It's going to look very, very similar, right? So it's going to be, I'm actually going to copy that function. Right, so it's going to look very similar, but it's going to call a function called apple wrapper. And what this will produce is, it's not going to produce an orange directly. It's going to produce an apple wrapper, and this apple wrapper will have another function, right? And we're just going to call it toOrange, right? Like this. So now scalar form is going to do its thing, but it's not going to compile because we don't even have the apple wrapper. So let's implement the apple wrapper. We're going to put it over here. It's just going to be a final class apple wrapper. Right, and it gets an apple, but it's not a function, right? So it's not a function, so it can just return an orange. We're going to do this extends any val thing just to save on some memory, and we're going to have this function toOrange, right? So apple is in scope now again, right? So we're going to have apple over here. I'm sorry, we're going to create an orange by apple dot weight in grams, right? So it's, the implementation is exactly the same thing, right? Like this, okay, like that. Okay, so now all we need to do is we need to have a helper method. We don't really need to, but we're just going to do that. Apple wrapper, right? So it's going to look pretty much exactly the same way as this one. In fact, I'm going to copy this one, right? So it's an implicit def, right? And I'm just going to call it apple wrapper. It gets an apple, but it doesn't produce an orange. It produces an apple wrapper, right? How does it do that? Well, it just says new apple wrapper. You should create a drinking game for me saying apple wrapper. It sounds kind of weird. All right. So now we don't need this, and we don't need that one, right? This is called an explicit implicit because at least you're calling a method on an apple that does not exist on an apple, right? So at least we know, oh, there must be some conversion from an apple to something. This apple wrapper, it actually doesn't matter how it's called, that will have the method toOrange. This is called an explicit implicit, and this is the foundation for most internal DSLs. In fact, this is exactly what Scala test is doing. If we go to map suite or to any suite, actually, look, for example, over here, we're saying, let me go, actually, let's go to the set suite. Let's go to the bottom. Things jumping around. All right, so look over here. So we have with some values. Now this thing over here is a map, right? It's a map. The map does not have the method should be, right? So somewhere there's an implicit in scope, probably brought in by this import, right? That converts a map into some map wrapper that has the method should be. And this is the foundation for most DSLs. By the way, this explicit implicits is also called extension methods or extension method pattern. So basically over here, we're extending the apple class with a method called toOrange. So all of a sudden, Apple has a method called toOrange. And because this is such a very, very, very common pattern, what we can do is we can just mark this entire class was implicit, right? And then we don't need this entire implicit def. It's going to behave exactly the same way. It will do exactly the same thing. It will actually generate a method called apple wrapper, right? So if I inline that, so now we're not using implicits, we're calling explicitly this method that you don't even see, right? The compiler generated it because we marked the class was implicit, right? So in this case, the name actually does matter, but we're going to discuss all the nitty-gritty details in the video about implicits. So what we can do now is instead of going to maps and adding this DSL on maps, which is the solution that we're actually going to stick with by the end of the video, I want to show you what we can do. We can take this entire class source, all right, and copy that to set. And what it will effectively do is it will save us this method, right? So we're going to go to set. We're going to go to the companion object, and we're just going to go over here and insert it like this, right? So now it will be an implicit final class, source, and I'm still actually not sure if I like implicit final class or final implicit class. I think I like this one better. All right, so we have with some values here, and we have with values, and what happens is that it also doesn't need those covariant parameters, right? Because it's its own thing, right? So effectively, what we can do now is we can remove these. We don't need them anymore, right? And again, we're going to discuss this in the video about implicits, but because this implicit is in the companion object of set, it will actually be found without any additional imports. So we're going to go here and I'm going to write test, and it's not going to compile because the number of the parameters doesn't match now. See, so everywhere where we're saying with some values in string, I'm actually going to mark all of them, and I'm just going to say, okay, let's just do string in there, right, like this. But in fact, now we don't actually need that, right? So everywhere where we say with some values, we can just do this, right? So what else do we have with some values over here? This one, string, empty with some values, yeah. Oh, there's one more over here. There we go. What else? Okay, so now I'm gonna create a bit more space over here so that you sort of see both of them, right? So you have now map with keys, set 1, 3, and some values, or set 1, 3 with some values. And then we're gonna have a teeny tiny discussion why I prefer the one of the maps. Now, here's the thing. You might look at this one and like it more, right? Because it's shorter, it's crispy. I get it. Actually don't understand. There's something corrupting about implicits. Like everybody who learns about implicits wants to use them right away, like freaking everywhere. I actually don't know what it is. Something about implicits, makes them feel so really cool. In fact, this is probably one of the most loved and hated features of Scala at the same time. But there is a reason why I waited almost 100 videos, which is almost like 2 years because I'm making only one video per week, that we're going to stick with the solution of maps, why I prefer it, even though it's a little bit longer. And the proper reason I'm going to tell you when we're going to have this video dedicated solely to implicits. But for now, I already can give you a few reasons. Number one, if I'm a developer learning a new library, like our Homegrown collections library, and I'm discovering the class map, it would be super handy if all the possible ways of creating a map would be right there, maybe somewhere in the companion object. Now, this is an ambitious goal, but in fact, most of the times, we're getting pretty close to it. So it works most of the times. Number two, the first rule of using implicits is this. If you're not 100% sure that you need them, do not use them. And again, I will explain exactly why in the video about implicits. Number three, implicits violate the principle of least surprise. If a necessary feature has a high surprise factor, it might be necessary to redesign it. Now, this principle comes mostly from the UI development, but it applies to software development as well. For example, if I look at our sets now, before we implemented the sets in, the method with some values inside of the set class, but now we're implementing them as DSL inside of the companion object for the set. Now, if I'm new to this library, my first question would be, why the hell is it implemented as a DSL? And it would be super not obvious to understand that the whole reason for putting this into the companion object was to just improve the type inference. And this is where comments come in, by the way. And if I look at the map companion object, then silly questions like this don't even pop up, right? Because there are no implicits, there are no fancy features. It's all good. And the reason number four is, all right, so these are all the 4 reasons. And for all of these 4 reasons, I'm going to go to the set and I'm going to remove this nonsense like that. There we go. Let's save the file and fix all of these tests. So this is exactly the same one. And over here, we're going to have map dot with keys. Just going to press Control J, Control N, like that. Have it over here. Where else? This one, map dot with keys, and that, and that, like that. and it's not called with some values, it's called and some values, right? So it's going to be and over here, and it's going to be and over there, and now I believe it should be fine. No, it's not fine. I'm actually not seeing the errors. Let's see what's up there. All right, it's upside off. Oh, if I removed too much. Hold up. I removed this one. That was too much. There we go. Okay, let's scroll down. Almost everybody's happy now. What do we have? Too much curly braces? Too many curly braces? Probably this one. Yeah, that looks better. And let's see if the tests are green. And yep, they're green. All good. All right, so the last thing that we're going to do today is going to be super important. This is another use case for implicits. It's actually not a super popular one. Let me show you this. So if you go to map, remember by the end of the previous video, we implemented a function called map values, right? So basically what it did was it called map, it left the keys alone, and it transformed the values, right? According to this function. Now it would be super easy to define a method called map keys like this. Map keys gets a new key, right? Drops the key function key, but this time it leaves the value alone, like that. Okay, what did I do? Jesus, was supposed to be new key over here. It was supposed to be value. It was supposed to be value. Transforms the key to new key. Not values, it's value. What's happening? All right. So we have map values and we have map keys. Both of them were super to implement. But if you actually look at the standard library, you will see that maps don't have a function map keys. And you might be wondering, if it's so super easy to implement it, why is it not there? And this is the reason. So what we're going to do is we're going to create an entire new test suite. We're going to call it referential transparency suite. All right. So we're going to go into here. Okay, so we're going to go to the set suite first real quick and copy the beginning like that. All right, so we're going to call it referential transparency suite like this. All right, we're actually not going to write any code, so I'm going to do like that. We're only going to write test. Okay, so we're going to have a test hello world. And it's going to be like that. It's going to be 1, should be 1, like that. And let's start running only these tests. So we're going to say test test only user dot referential transparency suite. Okay, we don't need so much space over there. Let's do something like that. All right. So what we're going to do here is we're going to write a kind of long test, and I'm going to show you why. The issue that I'm going to explain to you is not an issue for stats, but it is a big issue for maps. Okay, so let's have some value called Hulk Smash, and we're going to have a sat, and we're going to pretend as if we're writing the sat to the database and then reading it out, right? So we're going to say sat before DB was just a sat of 1 to 3. Okay, and let's say that after we read it from DB, the order was messed up. Now for sats, it doesn't really matter, right? For sats, because these are the same sats, so this is valid code. So the issue here is that if we do sat before DB mapped, where we're going to take the sat before DB, right, and we're going to map it to some value, right? So we're destroying all of these, all of the 1, 2, 3. We're mapping them to some value, and because sats don't have duplicates, this sat that will come out over here is going to have only one element called Hulk Smash, right? So we're producing a set of strings. We do the same thing for the other one. Set after DB mapped, right? It's going to be exactly the same code. In fact, I'm just going to duplicate the line, and over here I'm going to say it's set after DB, not mapped, set after DB, right? So we're doing the same operation to the set that was before we wrote it to the database and after. Okay, so the next thing that we're going to do is we're going to have some checks. So we're going to have set before DB mapped should be sat of some value, right? Let's see. Yeah, it's all good. So if we have after over here, should be some value, right? All good. Okay. So this means that because, the sets were the same before, right? So they were the same, right? Then after that, they should also be the same, right? After, reading them out and mapping them, they should still be the same. So set before DB mapped should be set after DB mapped, right? So this is basically the premise, right? So this is referential transparency, right? It means that you can just substitute them and get the same values. So the problem is that this doesn't work for maps. Look at this. Let's say that we have values, right? Which is the partial function of into string. And this is the same one as we kept using all this time, right? So it's going to be case 1 equals 1, case 2 equals 2, and case 3 equals 3. 1, 2, 3. All right? So now we're going to do the same trick for maps as we just did for sets, right? So we have map before DB, right, equals map dot with keys set after DB dot and some values, right? So we're creating a map after DB is going to be map dot with keys set after DB. This one was supposed to be before, before, right? And some values, right? So the keys are in different order, but it shouldn't be an issue, okay? Shouldn't be an issue usually, okay? So we're gonna go here and we're gonna have map before DB mapped, the same as we did for the sets, right? So over here we have map before DB, not mapped, map before DB dot map keys, and we're doing the same thing, right? So we're basically destroying the keys, right? Some value. Okay, and we're gonna do the same thing for after. Gonna go down over here, right? Map after and after. Okay, so now we're just gonna help ourselves with a few print lines. I'm gonna say, let's see the map before DB. What the hell did I do there? Okay, and we're gonna see map after DB. Map after DB like this. We're also going to make sure that they're the same. Let's see that. Map before DB equals map after DB, right? So they're the same. It's all good, right? So we see our print lines. So they're the same, right? The order of the keys is different, but 3 still maps to the Roman 3 and 3 still maps to the Roman 3 and so on and so on and so on. Okay? But look what's happening over here. Map before DB mapped. Map after DB mapped. Map before DB mapped equals map after DB mapped, right? Like this. Okay, so all of a sudden it's false, right? Because the keys were in a different order. They were attached to some values. Now another value survived this destruction of the keys, right? So we broke referential transparency, right? Because it's the substitution model, which requires referential transparency, says that if these, oh my God, this is wrong. If map before the DB equals the map after DB, right? Then map before DB mapped should be map after DB mapped, right? And that is not the case. That is not the case, which is why the test is red. I'm actually going to remove those print lines. We don't need them anymore. Okay, and this is the reason why map keys is not defined on maps, because it's super easy to break referential transparency and to just go freaking nuts and to rip out your hair because of bugs like this. Stuff like this actually happens in production every day. It's crazy. Right, so what we're going to do is we're going to ignore this test for now, like this. There we go. All right, so there is a way to have our cake and eat it too, so to say. So because map keys is so easy to implement, our users will end up implementing it anyway, right? So what we can do is we can put this into an extension method pattern, right? We can sort of hide it, and we will put it into an object with a very long and threatening name. So when they import it, they will think about it twice, because it's not going to be convenient, right? If you don't want people to use your code, make it as inconvenient as possible, and the other way around, make the right things easy to use. So what we're going to do is we're going to go to map, we're going to go down over here where we have this class source, and we're going to create another object, right? And we're going to call it very long, potentially dangerous implicits. Actually, many implicits are potentially dangerous. Okay, so we're going to have a final implicit class. We're going to call it map extensions key value, right? It's common to call this one self map key value extends any val, because we care about performance so much. And we're going to have map keys. In fact, I'm just going to copy map keys. Where is it? Map keys. So I'm just going to cut it out from there, bring it down over here. We don't actually even have any tests for it. Okay, so it's going to have self.map over here, right? And it should be already fine. So now in our task, we're being forced to do this. We're being forced to go in and to say, okay, let's import map dot potential. I mean, our users are going to be lazy, so they're going to do that, right? So they have to import all of this stuff just to make this compile, right? So we're making it inconvenient to them. And by the same token, we actually can go and add a few more, right? A few more potentially dangerous ones. One popular one is swapped, that it will swap the values and the keys like this, right? So all it will do is it will just self map case key value. It will just produce a tuple where the value and the keys are swapped like this. Oops, that was case. Oh, come on. Reload, whatever. Oh, come on. And there we go, case. All right. It's not keys, it's key. What's happening? At this moment, we're actually going to switch to running all the tests, and we're just gonna, because we already have this thing, maybe we'll need that in the future. We're going to add a few more. So we're going to have filter keys, and there's some predicate with key to Boolean. In fact, this one is actually not dangerous, so we're not going to add it over here. Filtering keys, there's nothing dangerous about them. So we're going to go back to the actual class, and yes, we have map values. Let's put it over here. So we're going to have filter keys produces a map with the same key, same value. There's even no need for covariance. And the same way as map value is called map, filter keys is going to call filter, right? So it's key. I don't care about the value, right? Just going to be predicate key. And the same thing is going to be for filter values. Filter values predicate. It's going to be value to Boolean. And it's going to create a map of key and value. And we're going to have the same way, filter, case. This time we don't care about the key, we just care about the value. And we're going to call predicate on the value. Now we don't have any tests for that, but I believe it's very straightforward to understand what is actually happening here. So the last thing that is left to do is just to commit it. So let's make sure that we add all the files, commit all of them like this. It's going to be video 23, and I'm going to call it internal DSLs like this. And let's push it. Push it. There we go, like that. It's pushed, almost. Yep, now it's pushed. So let me switch to my browser, refresh the page, and see our refactoring and our internal DSLs. Let's see what we did. All right, so we added the flight DSL, we added the implicits again. We have the filter keys, filter values. We have the with keys and values and some values. We also have the referential transparency suite. We added a bunch of tests for the maps. All right, that's all I got for you today. It's been my 100th video. Don't forget to like it if you did, subscribe if you want to improve the developer inside you, and most importantly, take care.